Thanks for having me. So let me share my screen. I will also move chat to a second window. So if you type anything in chat, I have it on the second screen. I'll try to pay a bit of attention to that. So if I do anything too fast or anything is unclear or you want to dive into anything, just try to stop me. Hopefully I will see it and then I can react right to what you have been typing. So hi, I'm Philip. I want to show you a bit how to debug an operator. And while I have a couple of slides, we will do most of this actually live. So I'll just run quickly through a couple of those. So I work for Elastic, the company behind the Elastic Stack. If you've never seen our stack, this is what it looks like. I will use our own operator running Elasticsearch, since it's also a pretty widely used data store for debugging, though what I'm showing you is pretty generic to any operator that you could run. So any knowledge that I'm sharing here should be pretty widely applicable. So for our specific operator, it can run Elasticsearch, what is storing the data. It can also run Kibana to interact with it and various other components in our stack. But I don't want to go too deep into our stack. The main thing that is sometimes confusing, we have an operator, though it's not called operator, but it's called Cloud on Kubernetes for good or bad reasons. Just don't be confused if you cannot find something called operator in our GitHub repository. It has this slightly confusing name. Don't be confused by that. It's an operator and it does what you would expect from it. And well, we have our custom resource definition, and we have a custom controller that brings it to life like any other operator. What is kind of relevant here is that our operator encodes a lot of best practices. So for example, whenever you set up a cluster, it will enable security and it will enable TLS security. So it will generate a self-signed certificate. So in your browser, you still need to accept that, but there is no easy way, at least, around having security and TLS turned on through the operator, which is not the case if you run the binaries yourself. There you would need to take care of that and generate the certificates, whereas our operator takes care of that and does a lot of the things that we know that are kind of like what we want. So I have already installed our operator, and then we'll deploy some YAML configuration files that will not work, at least at first, and we'll see how they can be fixed so that we actually have a working Elasticsearch cluster in the end. So that's pretty much the goal. And like I said, it is opinionated, it has best practices and like that operational knowledge encoded into it. That's why sometimes you might run into specific behaviors that we think are the right thing. Like if you do an upgrade or a change that requires restarts, it will do a rolling restart and it will make sure that the data is not moved unnecessarily between nodes and everything. That is all encoded in the operator already. I run that on one Linux instance since Zoom is always eating up all my CPU, so I don't try to run that locally. You probably could. I'm just using K3s to keep it simple and fast. So I have K3s installed. To get the operator, we have an all-in-one YAML in version 1.5.0 right now. We can check that it's running, or we could get all the pods in our namespace and we can see there is one instance of the Elastic operator running there. If you prefer to run this through Helm charts, we also provide Helm charts. We also have like standalone Helm charts without the operator pattern, but we also have Helm charts to install the operator. This is what I have already done. So I've used the all-in-one YAML from the previous slide to install that. So I kept it very simple and we have that running. And let me just check if it's really running and doing what I expected. And obviously, since this is a demo, I'm getting tired of always typing sudo here. So we have the Elastic operator we have running here. And then what I have prepared, basically, I have 3 bad configs, and we want to debug those configs to see what is going on. So what I want to do first is First, I run it because Elasticsearch takes approximately 1 minute to start, and then I'll show you what is actually happening in the file. So we are running the first one here, and let me quickly show you what is in that sample file. So that is like the hello world of how to run our operator, or how to run Elasticsearch in a single node and Kibana with a single node in our stack. So with any operator, you can see we have switched from Kubernetes concepts to kind of like Elastic concepts now. So we have the kind we have here is Elasticsearch and Kibana with our dedicated stable APIs for that. And I have just called this Elasticsearch instance quick start in the current stable version. We have a single instance in pretty much all the default settings, or keeping it as simple as possible. And then we have one instance of Kibana that we are linking to that. And then we are exposing that through a load balancer, so we can actually access that from the outside world as well. So does this work? If anybody can already spot something that is wrong or off, shout in chat. Otherwise, we'll try to work our way through what might be happening here, or how this is actually doing. So when I run get pods, I'm kind of confused because I specified, well, we wanted to have one Elasticsearch pod and we wanted to have one Kibana pod, but I only have a single pod here. So this is kind of odd. So let's see. You can nicely work with the resources that you want to target. So either Elasticsearch or ES works as well for Elasticsearch. So let me see what we have running here. So that looks okay. We have our quick starter running. It's a single node. It seems to be healthy in the version that we want. So what happens if we check out what is up with Kibana? And not much. This looks somehow broken, or not how it should behave. So the first place you probably want to get started in to see what is happening here is you wanted to check out the logs, and I'll copy that command because you probably don't want to see me type that. So in the Elastic system namespace, I want to see the logs for that stateful set application for the Elastic operator. And we have a lot of stuff scrolling by here. Let me find the start again. Okay, we could have piped that into less or whatever to make that maybe a bit simpler. But well, I didn't. Let's get or keep going with what I have started here. If I ever find the start. So you can already see that this is creating a fair amount of logs, and you probably don't want to step through all of those. And I can already tell you that even if you run through all of these log lines, you will not really see much in this example. Yeah, you might find this looks promising here. You can see that something is off here, that my reconciliation loop cannot reconcile something. And we could try to read that, but it's kind of like painful, and it's too early for me to actually go into the detail to read that. So rather than trying to read this very, very long log file, we'll do something else. We just describe the resource that is failing to see what is actually up with that. So we do a kubectl describe Kibana, because we want to see what is up with Kibana. So we see here, we have name is quick start. We have hit the right APIs. That's all where we want it to be. Further down here, or actually at the very bottom, we can see, and with the line break, it might be a bit hard to read, but we can see here we have the actual error message, or we have an association error. So the Kibana controller cannot find or associate with Elasticsearch. Why is that? Because we had a naming mismatch when we tried to link Kibana to Elasticsearch. And because Kibana couldn't start up properly, like the pod never went anywhere, and it wasn't this kind of like failed state. So what we see here is at the very bottom, Elasticsearch quick start was not found. So obviously we did that wrong. And that's kind of a common mistake that we see when people try to get started with the operator, that they link the resources together the wrong way. So let me head to VI sample. And now that we've talked about it, you can see here that the metadata name for Elasticsearch, we call it quick start. Here we call it also quick start, but that's not the relevant one. What we have here is this one here, the reference is also called, or is not called quick start, but is called Elasticsearch quick start. So we want to quickly change that. Maybe you would want to actually rename that to Elasticsearch quick start everywhere, but to keep it simple, I will just rename Kibana and keep Elasticsearch the same. And then we just apply that configuration. And that will then hopefully bring up Kibana the way it should. So let's see where were my pods. So you can see now suddenly more stuff is happening. My Elasticsearch instance is still running. That has been running for 5 minutes successfully. We didn't touch that or change that, but we are getting the Kibana instance. And we also have the load balancer that actually exposes that. And if you've ever complained about Java processes taking a long time to start, Elasticsearch is Java. Let's wait for Kibana to start. Kibana is a node application. It takes at least as long to start up. So hopefully while I'm talking here, after a minute or so, Kibana will actually be running. Well, we haven't hit the 1 minute yet, but in a moment or two, we will actually have Kibana running here. So just to look at only Kibana. Now we can see, okay, now it's green. Our quick start should be running that one here. So we can actually do one final check on the pods. You can see now it looks good. We have converged to a single Kibana instance, a single Elasticsearch instance, and we have our load balancer that we can connect that to. So let's see if we can actually access that. So this is Xera WTF, because WTF is always the right handle for any demo that hopefully works. This is the one we want to run. And like I've said, the operator sets up security by default for you, but it creates a private certificate. So we will need to ignore the certificate error here. But this is the actual instance that we have just started. You can access that one as well, by the way. But since we have set up security, the question now is, what is the password here? And getting the password is sometimes a bit tricky, and I will always copy that command because if you see me type that correctly, it must be a very special day. So what you do here is, we want to get the secret of that quick start Elasticsearch Elastic user. That's the default user that is built into Elasticsearch. And then we need to extract from the JSON that comes back that Elasticsearch user that is base 64 encoded. So we need to decode that. And when you run that, this will actually spit out that automatically generated password here. So I'm very careful to copy the right one here. And now the default user is Elastic, and the password is what I've just copied. And then if everything goes correctly, we are actually able to connect to Elasticsearch, which, give it a moment, looks like we're doing well here. Let's head to DevTools to just run one query. Let me make that slightly larger. So we run cluster health in the DevTools here. So you can see that is my quick start cluster. It's green. It created a couple of indices by default. So this seems to be a healthy node and seems to be all working as expected. So before I wrap up here, just for the handy shortcuts that I wanted to mention is, you can do kubectl get es. We can also take a look at a couple of resources at the same time. So I also want to see Kibana. I want to see the stateful set, I want to see the deployment, and I want to see the pod. So these combined here, you can see this is what we have running in terms of Elasticsearch. This is what we have for Kibana. You can see that is the one stateful set that we have defined that is backing our cluster here. And then you can see we have the deployment running, and these are all the pods that are up and running. So this is good. I guess we're done here, and well, we can clean up. So kubectl, this one we want to delete, my sample one. And in a moment or so, this should all be gone. So my pods will hopefully disappear in a moment. So they're terminating, almost gone. Okay, so that was the first example. For the second example, I want to switch gears a bit. And now I'm copying in a command that I'm creating, and we'll get into why this is maybe not such a smart idea in a bit. But let me copy in my kubectl command here. Now I'm creating the following file. So what I'm doing here is I'm starting on the Elasticsearch, no Kibana this time. It's called Elasticsearch sample in 7.12.1 with 3 nodes, because my cluster can probably not hold 3 nodes with the default settings where it would have 2 gigs of heap by default. I want to override that. So I will set each of my 3 containers has 1.5 gigs of memory, and half of that goes to the Java heap. So this is the setting that I want to run here. If you can spot the mistake already, shout in chat. Otherwise, let's start this and see how it is behaving. So I will just run this and it will create my pods. Let's see what we have created. Get pods is what I want. And you can see they are initializing. So we'll probably need to give this like 20 or 30 more seconds until we see that this is starting actually correctly. And while the pods will be starting correctly, it will not apply my settings correctly. So let's try that again. So we have our 3 containers running, and I will cheat slightly. We want to see the constraints on the container again. So I'm getting my Elasticsearch sample. So I pick just the first node here. I just want the information of that pod. I take the output as JSON, and then I just extract on the container what have I set in terms of resource definitions or resource limits. It uses the default limit of 2 gigs, which is not what I wanted here because I set the resource limit to 1.5 gig. So somehow that failed. Also, if I look at the specs of what should be applied within the container, like we have a lot of settings here, but we will not find the heap setting to 750 megabytes each pod. So that is simply not there. Something went wrong here. So let's look at what we have actually applied on our service. So this time I'm using my Elasticsearch sample. That was the cluster that I've created. And now I want to see the output as YAML. And when I look at this, you can see this looks like what we have configured. The allow memory map files false we have set. We have the 3 nodes. We have a pod template, but there's something missing in the pod template. We don't have our resource limit set here. Why is there no resource limit? And we can fix that because we have done what we always do wrong in Kubernetes, in YAML. We have done the indentation wrong. So if you scroll up a little bit here, this indentation here was wrong. And that's why all of this was out of place and wasn't being applied. So let's fix that. We can just copy that in. Now I'm doing a kubectl apply rather than create. My indentation is fixed now. Now my pod template is correct. It will warn me about saving that and doing the diff, and that's all good because it will do the right thing. And we can actually watch how my pods are being restarted. So I'm running a watch kubectl get pods just to see that we're doing a rolling restart now. So we are terminating the pod 2 right now. Now it's pending and it will be replaced. It's initializing and we will rotate through all 3 pods to replace them, start them with the right memory limits, and then they will be running in the state that we want them to. So again, we'll need to probably give this a moment or two because, well, the first one is only 20 seconds into the restart process. After a minute or so, that pod will be up and running. Once that one is healthy, we will go to the next one, replace that, and so forth. You will not lose any data because any data that is already in your cluster will just be re-replicated to the other ones. I will share the final file. It's, by the way, the entire setup is on GitHub as well. I can share the presentation and the GitHub link or the link to the repository afterwards. So you can get all the broken YAMLs. Don't use them in production unless you want to spend time debugging. Okay, so we are replacing that one, this one here, the number 2 is running and has been replaced. 1 is also running. One is also running now, and 0 will probably be replaced in a moment. So it will take a couple of more moments, but then we will actually be fine and see that this is working. So let me run my commands from before. Let's look at resources. We'll take a moment until, let me switch that to the one of the replaced containers. So I think 2 was the first one that we have replaced. And you can see now our limit is applied. As soon as the 0 pod has been replaced as well, then the resource limit of that one will change. One thing that you might ask now is like, why is your operator so stupid and doesn't catch that error? And the problem is that we have kind of cheated here. Or maybe not cheated, but rather than saying kubectl apply, if I find my command, we said kubectl create, and with create, the JSON structure is deserialized and created into an object structure, and what cannot be mapped is not even sent to our operator. So there is no way for a webhook to actually find that. Only if you run apply rather than create, it does that diffing and sends the original JSON structure that you had, or YAML structure, so that we can actually find that. So just to make that clear again. So I will delete all the clusters or nodes that we have running here, since we're also running a bit low on time. And let me go up to my initial command. So you can see this is what we ran here, and this didn't throw an error. What you want to do here, rather than running create, if you run apply here, then this will not actually work, because with apply, there is an annotation with the diffing that will actually tell you that in that pod template, there is a setting that it doesn't know, and it fails. But if you run it with create, it is not sent to the operator, so the operator cannot actually catch that bug. So we definitely recommend to run apply all the time and not create, just because we can do a bit more error checking if you do the apply rather than the create. Okay, final example. This one might be slightly more complicated. Let's see how far we get to this one. We want to apply that, and that's sample 3. And I show you what we have in sample 3. Again, it's relatively straightforward. So we have a 3-node cluster. Now I want to add a volume claim. So in the end, every node set is a stateful set that is backed by a volume claim for the persistent volume running the data in the background. So that's kind of like the steps of the mapping that you need to keep in mind. And what I'm doing here is I'm creating a specific persistent volume claim that I want to have an Elasticsearch data, or that's the name I can reference it on. And I have a read write once access mode, and I only give it 1 GB of data, which is not a lot. And I use my own storage class Elasticsearch. So while I'm talking, let's see, kubectl get pods. What is this doing? And my pods are in the state pending. And we can keep waiting here, but they will be stuck in waiting for a very long time. So what do we do? Let's get, let's take a look at this one here. So, sorry, I wanted to do a describe. kubectl describe pod. This one here I want to describe. And at the end of the describe, you can see something went wrong with our persistent volume claim. Now we could take a look at just that persistent volume claim specifically, though that does not reveal a lot of relevant information. So here, for volumes, this doesn't tell us a lot what is going wrong here. What we want to do instead is we want to actually look at the persistent volume claim. And you can see that my persistent volume claims are still pending. So my storage just has not been created. So we can do a describe on these again. And that one tells me then, this is kind of like the solution. There is no storage class Elasticsearch, like I just made that up. So we will need to change that storage class. Let's see if we can quickly get that done. So we have a storage class, and actually what we need to do is we need to do a kubectl get storage class. If I would store H class, if I would type that correctly, and you can see the only storage class that is available on our cluster is local path. So we do need to change that. So the only storage class that we can use here, unless we create our own storage class Elasticsearch, would be this one. The problem, once we apply this one here, kubectl apply sample, is that, and it's again a pretty long error message, but at the end you have the relevant thing. The volume claim can only be increased, but I cannot change it. So we would need, since we don't have any working data in here, we would need to destroy the entire cluster to actually redo that. If you have existing data and you want to change the storage class, you could do that in the rolling restart by adding a new stateful set that will get rotated over. So replacing the storage is kind of one of the more tricky operations. Also something that is a bit trickier to debug because you need to know how they are combined. But for any data store, that's kind of like where the more interesting parts are. Since we're running low on time, I have all the steps and everything in the slides. I will share the slides afterwards. Yeah, once you have the cluster running, you could obviously use the Elastic Stack to monitor the Elastic Stack just to get the logs and see what is up and running. But I wanted to keep it simple and on the shell today to keep that an easy operation. With that, are there any other questions since we're running pretty short on time? And I will dig up the references to the bad samples and the slides and send you the link right afterwards. Any questions?
So we have still like more than 5 minutes left for questions and answers. So if you have questions, then you can ask them now.
Now is your chance. Otherwise, if we have 3 minutes left, I will try to fix my setup here because we didn't fully fix that one, get pods, because you see it's still pending. We have never finished to start up our cluster because what we need to do is So I'm just creating a new node set. And that will then replace my existing nodes, and then this will all be fine. Final chance for questions now. While this will take a moment, but this will initialize new pods, a slightly different name, but those will then be up and running. I see we have a question. Do we maintain a state machine diagram? To be honest, I have not seen a state machine diagram. You mean of all the possible error states, or just the states more on the Elasticsearch side, so that the cluster is going through? Because for the operator itself, to be honest, no, I have not seen that. It might actually be an interesting idea to see that, to like from what state we go into what other state. It's a good point. I don't think we have like a nice diagram for that, to be honest. Okay, cluster fixed. We managed to do everything in 30 minutes. Final chance for questions. Otherwise, I'll get you the links for the resources.
Thank you, Philip. So
thanks for having me.
Perfect in time. And thanks for this informative session. Yeah, I mean, you've already answered the question that you will share the link on GitHub in the repository. Besides that, I'm pretty sure they can reach out to you via Twitter, LinkedIn, whatever. Yeah, but thank you for being here with us today.